Hi again, this is the video containing the solution to the number 4 of assessment number 2. It says an observer at the top of a 40-meter high building observes that the angle of depression of the parked car is 78 degrees. How far from the base of the building is the car parked? So in any problem, may it be in algebra or trigonometry, the best way to understand a problem is to make a diagram. So it says an observer, okay, at the top of a 40-meter high building. So maybe we can start with by sketching a 40-meter high building. So we can use a 20-meter high building. So it's up to you if you make an actual building, but for most, or in most cases, you just have to make a vertical line. But just to make it look like a building, so we'll draw a building. So with windows. And then on top of this 40-meter high building, there is an observer. Now for bigger objects, we don't need to really identify what's the height of the observer, but we can assume the observer as a point on top of the building. So here is the observer. And then it says the angle of depression. So this observer is looking at the parked car, and the angle of depression is 78 degrees. So let's assume the car is somewhere here. Okay, so this is the car. So the observer is looking at the car at a 78 degree angle of depression. Now, be careful when you indicate or when you identify where the angle of depression is. So keep in mind that the angle of depression is measured from the horizontal line, from the default line of sight of the observer. So the default line of sight of the observer is the horizontal line. So this is the line of sight. So if there's an angle of depression from the line of sight, so you measure that angle of depression from the horizontal line. So this is the 78 degrees. Common mistakes in angle of depression problem is that when a student or when someone sees that there's a triangle formed here, they usually put the 78 degrees here. So don't commit that mistake. So keep in mind the angle of depression is always measured from this horizontal line down to the new line of sight. Okay? So as you can see, although it's not yet complete, you can imagine or you can actually make a triangle from the diagram. Now for the building, so we can always assume that the building and the ground will have a 90-degree angle. Okay, so if I will redraw this triangle, so this is the 40 meters height of the building. This is the 78. So there's the 78 degrees. So if this is 78 and we know that this is 90, then this angle must be equal to 12 degrees. 78 plus 12 is 90 degrees. Okay, so with that, so if you're looking for the distance, how far from the base of the building is the car park, so we're looking for this distance, then we can use this triangle to solve for this. Again, there are just three options. Either use sine, cosine, or tangent depending on the given information. So how do you determine if you have to use the sine, the cosine, so SOHCA, TOA? So how do we know if we have to use sine, cosine, or tangent? You base it from the given information. So if we consider this angle 12 degrees, then this side is the opposite side. And this side is the adjacent side. So you can form an O opposite and an adjacent A. So that means that the function that you're going to use is the tangent, TOA. So how to set up the equation relating the x, the 40, and the 12 degrees. So we use tangent. Tangent of 12. So take note, I'm not using 78 because 78 is outside this triangle. So tangent of 12 degrees is equal to the opposite side, x, over 40. So to find x, we multiply this both sides by 40. So this will give us 40 tangent of 12 degrees equals the value of x. And then we just need to compute the exact value for 40 tangent of 12 degrees, and that will give us 8.50. Okay, so the value of x is 8.50, and that is in terms of meters. So that is the distance of the car parked from the base of the building. Okay, so this is the distance. How far from the base of the building is a car park? It's 8.50 meters. Okay, so that's it. That's the solution for number 4.